Hey everyone, hope you're doing well. We are nearing the end of this semester, so I thought it would be a good idea to go back and review some earlier concepts that you may have learned in grade 10 math. It's probably been a little while, so it's always good to review before exams. Today I'm going to be looking at lines, bisectors, and distance. And let's get right into it. Question number 1 says, a line has endpoints -2, 6 and 4, 14. What is the equation of its perpendicular bisector? And what I like to do is I like to draw this out first. So here's our line. I can do a better job connecting those points. Let's try that again. I'll deal with it. Okay. What is the equation of this line's perpendicular bisector? So before we can move on, we really need to understand what this means. What is a perpendicular bisector? All it is a line that's going to cut our original line in half, and it's going to do this at a 90-degree angle on all sides. So this is our perpendicular bisector, but we don't know what its equation is. However, we can use a little trick, and that is the slope of the bisector is going to equal the reciprocal slope of our original line, and that is always true. So our first step is actually to solve for the slope of our original line, and we can do that with our rise over run equation because we have 2 points to work with. So I'm just going to rewrite my points here. And now we just have to plug in those values. So y2 is 14, y1 is 6, x2 is 4, minus -2. So we have to make sure we keep the negative there. And what happens when we have two negatives? This is going to turn into a positive. So that gives us 8 over 6, which is the slope of our original line. I can simplify this fraction a little bit if I divide both the numerator and denominator by 2. So let's do that. And now I've got 4 over 3. But we're not done yet. We need to figure out the reciprocal of this slope. And the way we do that is we're going to flip the fraction upside down and change its sign. So in this case, we have a positive 4 over 3. If we turn it into the reciprocal, we're going to get a -3 over 4. Okay, that's the first step. But when we think of a linear equation, we want to write it in y equals mx plus b form. And we only have the slope so far. We don't know what b is. And the way we're going to solve for b is we need to plug in a point that lands on this line to solve for our missing value. And if I go back to my little sketch, if we think about the perpendicular bisector cutting our original line directly in half, that means that it must travel through our original line's midpoint. So if we solve for the midpoint, I know for sure that point lies on the reciprocal line, and we can use that in our equation. So let's get our original points again. We need to solve for the midpoint. And the way we do that is with a midpoint equation. We're just going to add our x terms together, divide by 2, and also add our y terms together and divide by 2. So we've got a -2 plus 4 over 2. Let me just make sure I keep my brackets there. And then a 6 plus 14 over 2. So the x value of our midpoint is going to be 1. And the y value will be 10. Now all that's left to do is plug that point in to this half finished equation. So y is going to be 10, and x is going to be 1. I'm just going to rewrite this fraction as a decimal. So -3 over 4 would be a -0.75. And to isolate for b and solve for it, I need to move this over here. So this is our b value. And if I rewrite the entire equation, it will look something like this. So this question is a great intro because we need to know what is a bisector, specifically a perpendicular bisector. What is its slope? And we got that from our original line. And finally, what is a point on the bisector, which in this case is our midpoint. Okay, hopefully that wasn't too bad. Let's move on to question number 2. A little bit trickier. What is the shortest distance between the line y equals 1 over 2x plus 10 and the point -1, -3? Once again, let's do a quick drawing. This is our 1 over 2x plus 10 equation. And I'm going to put the point -1, -3 a little bit lower. Okay, so the goal is to figure out what the shortest distance between this point here and our line is. So we need to know what is that distance. Now, we are going to have to use the same concept of a perpendicular line because the shortest distance from this point to the line, A, has to be a straight line, and B, it has to be a line that is perpendicular with our original line. So it's going to look like that. If you want a quick explanation for that, it basically has to do with Pythagorean theorem. Because let's say I'm standing in front of a wall, and I'm thinking, okay, what is the shortest distance between me and this wall across from me? I could travel at an angle this way, or maybe this way, but no matter what, the shortest distance is always going to be perpendicular to the wall. Right? Because if I go towards the wall at an angle, or at any angle that's not exactly perpendicular to the wall, I'm creating a longer distance. And this is shown with Pythagorean theorem, where the hypotenuse of a triangle is always going to be larger than any of the other two sides. So if I go straight ahead, I'm standing on the shorter side of the triangle. But if I go this way or this way, it's actually going to be farther away. So that proves that we need the perpendicular line here to solve for distance. And it's not going to be a bisector because we don't know that we're cutting the line exactly in half. That's not what we're doing. But we do need the reciprocal slope of our original line. We know we have a 1 over 2 in our original line. If I flip that over and change the sign, I get a negative 2 over 1, or simply negative 2. So that gives me a shell of our linear equation. We still want b. Now, I can't use the midpoint of my original line because, again, we don't know that this reciprocal line cuts our original line in half, but I can assume that our point of negative 1, negative 3 is going to reside on the line because we're using it to solve for the shortest distance. So we are going to assume that our line hits that point. That means we can plug it in to solve for b. Need to move this over here. And my b value is negative 5. So I have a new equation that looks like this. But we haven't solved the question yet. All we've done is solve for the equation of a line that passes through this point and also could be used to represent the shortest distance between that point and our original line. But we still need to figure out a point where our two lines intersect. And that would be right around here. The reason why we need that point is because we're going to use that point to solve for the distance between these 2 points, and that should be the shortest distance that we're looking for. Now, the way we're going to solve for that is we need to solve a system of linear equations. Let me rewrite those equations here. Okay. And when we have two linear equations, we have a couple of options when solving for where they intersect each other. And we have a couple of options when deciding how we're going to solve this system. We could do substitution, where we basically set one variable from one equation equal to that variable in another equation, solve for that value, and then figure out what our point is. Or we could do elimination to eliminate one of the variables. So I'm going to go with elimination because it'll be a bit faster. So if I subtract one of these equations from the other, that will eliminate my y value. That gives me a 0. Now we have 1 over 2x minus negative 2x plus 10 minus negative 5. So make sure you're keeping track of your negative values because we're going to have to cancel those out when necessary. So this looks like adding these two terms together and adding these two terms together. So that's a 2.5x plus 15. I want to isolate for x, so I'm going to move this over here. And negative 15 divided by 2.5 is a 6. Negative 6, to be precise. Okay, so The x value that we need is -6, but we need to plug that back into one of our equations to see what the y value would be. So let me use this one. -2 times -6 is a 12, minus a 5 should be a 7. So now we've got a second point to work with. So this is where our two lines intersect each other. And we also have our original point, which was -1, -3. So now all we need to do is figure out the distance between these 2 points. And for that, we can use our distance equation. And it looks a little something like this. So let me just label my points here. And if we plug all of this in, I'm running out of space, so I'll just put this over here. -1 minus -6. The negatives are going to cancel out, so it'll be a -1 plus 6, which should be a 5 squared, plus -3 minus 7, -10 squared. That will be a 25 plus 100, and that ends up being the square root of 125. Now, we weren't given any units of measurement in this question, so really the answer would just be the shortest distance is the square root of 125 units. And I really like this question because if you can answer this question, you're probably good for the majority of this unit in grade 10 math because it involves so many different skills. You need to understand finding slope, finding reciprocal slope, figuring out the intercept of a linear equation, and also figuring out distance between 2 points. So if this question went well for you, great job. You should be good to go. Thanks for watching and happy studying.